Okay, simplifying rational functions. This is really, really important, and people struggle with it. It's not as bad as it looks if you don't mind staying with me for just for a second. It's like anything else. Look, if we're going to add these fractions, 4/5 plus 3, I don't know, 3/4. What we would do here, isn't it? We would look for a common denominator between 5 and 4. And the least common denominator would be the least common multiple of those two. In this case, right, the least common denominator, the LCD, would equal 20, right? So how would you do that? Well, you would do this to get this to 20, right? You want an equivalent fraction. You would multiply this number by 4 over 4. I remember my elementary math teacher saying, whatever you do to the denominator, do the same thing to the numerator. And I don't know why he said it that way. I don't know why he didn't just say multiply by 1 and use the one that's most convenient for you. Because if you ever ask yourself why is it okay to do this? Because if you look, 4 over 4 is 1, isn't it? So that's all we're really doing. In here, we'd multiply by 5 over 5, wouldn't we? And we'd get 4 times 4 is 16, isn't it? It's 16. 4 times 5 is 20, isn't it? Plus 3 times 5, that's a terrible color, I'm thinking now. 3 times 5 is 15, right? So 15, and 4 times 5 is 20, right? So we have these common denominators of 20, right? And of course, remember with fractions that once we have a common denominator, we don't add denominators, so it stays the same. And then we just add numerators, don't we? So 16 plus 15 is 31. So that would be our answer, wouldn't it? So if you're sitting there going, Charlie, why are you telling me all this? I want to get to this. Because the truth of it is that this is all just fifth grade math. It just looks a little bit, it just doesn't look as good. But we can definitely do this. So let's follow the same thing that we did down here with the problem up on top. And I think that we're going to find out that this is very, very doable. Okay? So stay with me, please. Look, so here, look, this is similar. So we have a factor of 4 down here. We have a factor of 5 down here. So the question is, what's the least common denominator? What's the least common multiple of that? And it's 20 again, isn't it? And then look, well, let me use a different color, you guys. We have x squared here, don't we? We have x squared here, and we just have a single value factor of x here, don't we? So what's the least common least common multiple of those two? Well, it's x squared, isn't it? Right? So we're going to multiply this side over here to get this. We want this to be x, this side here to be x squared also, don't we? So we're going to multiply this by x. Remember, it has to be x over x, right? And then we also want it to be 20. So 5 times what is 20? And it's 4, right? So it's 4. So we're going to multiply this side by 4x over 4x. And of course, 4x over 4x is 1. So that makes sense why that's okay to do that, doesn't it? And then what about here? We want a factor of x squared. We have it. We want this to be 20. So 4 times what is 20? And it's just 5, isn't it? So we're going to multiply this side by 5 over 5. What I want you to pay attention to is that the numerator stuff is just kind of a pain in the neck. It just happens to go along. But what we're trying to get is down here at the bottom. And look, 5 times 4x squared is 20x squared, isn't it? And 5x times 4x is also 20x squared, isn't it? And the rest of this stuff at the top is just coincidental. We're just following rules because, of course, this is just 1 and this is just worth 1. We're just multiplying it by 1. So 5 times 6 is 30, right? Over 4x squared, right? Plus, and let's do this, 2 times 4x is 8x, isn't it? 8x. And then 5x times 4x is, oh wow, did somebody tell me to do that and you let me, 20x squared, right? So here is also 5 times 4 is 20x squared, so 20x squared, right? And look, we have common denominators. We have a denominator of 20x squared down here and a denominator of 20x squared down here. So we have a common denominator. We don't add denominators. So we're going to have a denominator of 20x squared. And then we have this. We have 30. We have 30, right? Plus this plus sign right here is this plus sign right here, plus 8x. And of course, 30 plus 8x is just 30 plus 8x because we don't know what the value of x is, right? So there's our simplified answer. Okay? So that's number one. Let's look at another one. Just one more and we'll be done with this, I think. See if you can start to figure out what I'm going to do here. I'm going to try to simplify. I'm going to change this color in a second. Try to simplify. 7 over 6 times the quantity x minus 2 minus x plus 3 over 6x. Okay, this gets kind of weird. I want to show you this because this is where people start to screw these things up. It looks like this is 6x and it looks like this is 6x and they're the same, but they're not. And look, so this has a factor. Here are the factors in this one. This one here has a factor of 6, right? And so does this one. So this one has a factor of 6, right? This one, however, has a factor of, of x minus 2, right? So of x minus 2 here, right? But this one on the other side here has a factor of x. You got to really get that this piece right here is a factor. X minus 2 is the factor, and this is a factor. So this gets a little bit more difficult. So we know we don't have to multiply either one of these by 6, do we? We have that part. This side, though, we're missing this factor right here, right? We're missing the factor of x minus 2. We don't have, there's a factor of x minus 2 over here, but not over here. So remember, we have to do x minus 2 over x minus 2, right? Now look at this for a second. This one has the factor of 6, just like this one, has the factor of x minus 2, just like we created for this one, but it's missing a factor of x, isn't it? So we'll multiply by, I'm going to put the x out here if you don't mind, by x. Now this has a factor of x, so does this one. This one has a factor of 6, so does this one. This has a factor of x minus 2, and so does this one. But remember, if we're going to do this, we have to put x over x. Please remind me why x over x. Because a number over itself is 1, right? So we did that here, didn't we? Now we have to actually do some of this work. So we're going to have x times 7 is 7x, isn't it? 6 times x is 6. So let's look at it this way. Is 6x x minus 2. Isn't that right? All right, you guys. This negative sign right here is this one, right? And then we have 6x times x minus 2 is, trying to keep it color-coded, is 6, this x is this one, times x minus 2, right? But remember up here at the top, remember this negative sign here, right? Now we're going to have this x plus 3 times this x minus 2. Look, this x minus 2 is this one, this x minus 2 is that one, right? And all the rest of the pieces should fit together, shouldn't they? Now, we can keep simplifying from here, and we should. Just going to keep simplifying. So, really weird because when you get to calculus, you simplify a lot less. But in Algebra 1 and Algebra 2 and actually college algebra, you're asked to simplify to death, frankly. So keep simplifying. And it's a cool thing because how that will help you in calculus is you'll be able to see how these pieces fit together. So let's keep simplifying. I guess what I'll do is this, if you don't mind. I'm going to do this, right? I'm going to do FOIL here. FOIL. So, right, I'm just bringing my math down. X times x is x squared. X times negative 2 is negative 2x. 3 times x is positive 3x. Positive 3 times negative 2 is negative 6. Isn't that right? I can simplify these two things. We have negative 2x plus 3x is positive 1x, isn't it? Which is a little bit of subtraction there. So it's positive x. So far, so good. All over. Now, what do I have here? This, you guys, is this, isn't it? Right? This is not a b, this is a 6. Right? So far, so good. Right? Okay. Keep in mind, though, we had that negative sign. This negative sign right here is this negative sign, isn't it? Sorry, this 7x is this 7x. Stay with me for just a second because now we have these common denominators. We don't need to add them, right? If we had 1/3 plus 1/3, we'd add the numerators, right? We'd add the numerators and get 2, but we would not add the denominators, right? We'd get just 2/3, wouldn't we? So in the same way, we don't add or subtract these pieces right here, do we? So we still have that common denominator of 6x times x minus 2, don't we? Now from here, this becomes a This becomes a call here, but I guess what I would do here is I would distribute this into here. I would distribute this negative sign and put it here, here, and here. God, this turned into a lot of work, isn't it? So we have 7x minus x squared minus x plus 6. You cool with how I got all that? This 7x is this 7x. Negative times a positive is this negative. Negative times a positive is this negative. Negative times this negative is a negative here, isn't it? All over that same 6x minus 2. You with me so far? Hello. Wow, that was interesting, wasn't it? Right, and we can simplify that out some more. 7x's minus x is 6x's, so that gives us 6x minus x squared plus 6 all over this 6x x minus 2. My God, you could keep going forever, I think. This problem has turned into a bloodbath. So, but you know what, I'm going to put this in good polynomial form. So this, right, that's our lead coefficient. So negative x squared, right? This is positive 6x, isn't it? Positive 6x, isn't it? Plus 6 all over 6x x minus 2. And usually what they want you to do is factor out this negative sign and put it out here. I'm not going to do it. I'm not going to do it. I'm going to call that a day. So really good work, right? Try to keep in mind, please, that find the least common denominator. Start off with that. And always have the idea in your mind that this is the same 5th grade fractions that you've been doing forever, okay? Good work.